Now, just a few words about the model we are running, the system we are running. The system has been developed in the scope of a project that we named EPREV. It was an absolutely private financed project, so we got money from the wind farm promoters in Portugal, most of them, and the more important ones. And during a couple of years, we developed this system. So, how does it work? It is based in the wind forecastings that are produced in the University of Lisbon using MM5 and NSEP boundary conditions. So for now about 40 to 50 wind farms, we get forecastings for the wind, and then we run a lot of statistical models, an ensemble of statistical models, let's say, that using this wind forecasting try to give us a guess for the wind, for the power that is going to be produced by the wind farm. The important thing here is that from the very beginning we found it was absolutely crucial, and the system runs so, that the wind farms feedback our system. So we produce 4 forecasts per day, so one forecast every 6 hours, based on 2 forecasts of the wind, and also 4 times a day the wind farms feed the system with the operational data of that day. Of course, it makes things easier to run. When the wind farms, by some reason, are not able to feedback the system, the forecasts are of worse quality. There are other details of the system, but I have no time to describe it. One very important issue that I would like to mention, a wind farm and a forecasting system for a wind farm performs very differently if we have historical data of the operation of the wind farm or not. For the cases we have historical data, we perform what we call training, the training of the statistical models, making forecastings of the wind for the past, for the time of operation of the wind farm, and with those forecasting and the historical data of the wind farm, we train the statistical models in such a way that they can learn by themselves, between commas, and give better forecastings. Oh, I'm sorry. Well, that's how the system operates. Now, a couple of answers, a couple of questions, and I'm reaching my hand. There are, of course, many questions about wind power forecasting. One very common question is, how can we get good forecastings? Well, there are many answers in the literature, using different numerical weather prediction models, using robust and advanced systems. Most of the people that started making these forecasts were not meteorologists, but very soon we realized that meteorologists are very important for us. We know how a wind turbine performs, but not how atmosphere performs. So thanks to the meteorologists. And some different issues that are now being implemented, models for the forecasting of ramps. I heard from the previous speaker that it is perhaps something that can be a reality not very far from now. And it is very important to have also modules for the forecastings of very short term. These we overcome with the statistical models, not with physical models. So I'm going to jump these improvements that are undergone now. I hope that my colleagues can read it in Portuguese. Many things are being done, in fact, in this subject. For instance, ourselves in EPREV, and ProWind is a company that is now being funded to do this work in continuous. So we have a lot of things that we want to do in the next future, improving, of course, our system. Now, just one word about the value of the forecasting. Just one word. Many people ask us, but how much does a good forecasting value in terms of money, because it is of money that we are talking. There are many approaches to the system. It's not easy to the question. It's not easy to answer. Just to give you two figures for you to have an idea. Garra da Sun is a well-known and established since very long in the domain, performed some calculations for the UK market and also for the Spanish market, and they arrived to the conclusion for the Spanish market, that is the one that is closest to us, that the value of a good forecasting in the electricity market can be as big as €7 per megawatt hour. And for an isolated wind farm, for a portfolio of wind farms, a medium-sized portfolio can be as big as €3 per megawatt hour. Well, I hope you are aware about prices of energy. €7 per megawatt hour is about 10% of, roughly 10% of the price of energy in the market. This is a very important figure to be kept in mind. Finally, and this is my last slide, what's the ambition of people that works in this domain? Because we have to look a bit longer to the year 2030, and the Wind Energy European Technological Platform says that what we would like to have in 2030 is that we should be able to assess the wind potential with an uncertainty less than 3%. And it means long-term, very long-term forecasting. We should be able to know the detailed characteristics of the wind with an uncertainty less than 3%. And it means that very good information is to be given to the designers of wind farms and designers of wind turbines. Finally, for short-term forecasting, the aim, the target is also to have forecasting with an uncertainty less than 3%. This is certainly very, very ambitious. There are many things to be answered meanwhile, but I don't know how and if it can be reached, but for sure that meteorologists will have a very important role in this. Thank you very much for your attention.